welcome back to the deep dive. Today we're going deep on something that honestly underpins so much of the digital world that we all interact with every single day. We're talking software testing.
Yeah, software testing. It's kind of the unsung hero that ensures your favorite apps, they don't just crash randomly, that websites actually work as promised, all that good stuff.
It's that invisible layer that we often take for granted, but when it's not there, oh boy, do we notice.
Exactly. And it's not just for techies,
Yeah.
right? I mean, whether you've been super frustrated by a glitchy app or you're someone who's actually building the next big thing in tech, understanding this fundamental process of software testing, it gives you this real insight into how we actually build reliable technology.
Yeah, I mean, think about all the times you're trying to do something online and it just doesn't work. It can be so frustrating, and that's where software testing comes in.
Right. So consider this deep dive, your crash course or maybe your refresher on everything software testing.
And we're going to try to keep it really clear, really focused, breaking down the core concepts, understanding why testing is so crucial, and those guiding principles without getting too bogged down in the weeds, no jargon overload here.
Absolutely. We'll keep it practical, keep it relevant.
Okay, so first things first. What exactly is software testing?
Well, at its heart, right, software testing, it's all about putting a piece of software, a product, an app, whatever it is, through its paces, right? Mm-hmm. We're trying to see how it behaves under different conditions.
Okay, so pushing it to its limits, seeing if it cracks.
Yeah, pretty much. Mm-hmm. And there are two main things we're trying to do. One is verification, right? Mm-hmm. So does the software do what it's actually supposed to do based on, what we wanted it to do?
If it's supposed to, I don't know, calculate something, does it actually give you the right answer?
Exactly. And then the second thing is identification. Can we find those hidden defects or bugs in the code, those little gremlins causing trouble?
Right, because sometimes it might seem like it's working, but there's something lurking underneath.
Oh, yeah, under the surface, exactly. So it's not just about, fixing those obvious bugs. It's also about making sure that the whole experience of using the software is smooth, reliable, and actually enjoyable.
So making sure the user doesn't pull their hair out in frustration, that's a key part of it too.
Absolutely. It has to be user-ready, not just technically functional.
Okay, I'm getting the picture. So I think a lot of people might wonder, why spend so much time and effort on this? Why is testing so important?
Well, I mean, think about it. Software is everywhere, right?
Yeah.
It's in our phones, it's in our cars, it's running our hospitals, our banks. So if that software fails, the consequences can be huge.
Yeah, you don't want your car suddenly breaking because of a software glitch.
Exactly. So first and foremost, testing is a safety net. It helps prevent those critical failures by catching those bugs early on. And it just improves the overall quality of the software, right? You get a more stable, dependable product that people can trust.
And that trust is so important, especially with everything moving online these days.
Right. And then there's the user, right? When software works as expected, it just makes people happy.
Yeah.
And happy users, they're more likely to stick around, use your product, all that good stuff.
It's all about that user satisfaction. So we've got the safety aspect, the quality aspect, the user satisfaction aspect. Anything else?
Oh, yeah. There's the financial side of things too, right?
Mm-hmm.
Finding and fixing those bugs early, way cheaper than trying to deal with a massive meltdown after the software's already out in the wild.
It's like preventative maintenance versus emergency surgery.
Perfect analogy.
Yeah.
And then you have industries with really strict regulations like healthcare or finance, right? Testing is non-negotiable there. You got to make sure things are secure, data is protected, all that.
Makes sense. So where does this testing actually happen in the whole software creation process? I've always kind of thought of it as one of the last steps before you launch something.
It's a common misconception. Yeah. A lot of people think that. But actually, testing, it's woven through the entire software development lifecycle, or what we call the SDLC.
The SDLC, okay, what's that exactly?
So it's basically a roadmap for building software, right? It starts with figuring out what the software needs to do. Those are the requirements. Then you move on to the design phase, like planning out how it's going to work. Mm-hmm. And then you actually write the code. That's the development phase. And then comes the testing, followed by deployment, which is putting it out into the world. And then maintenance, keeping it running smoothly.
So testing isn't just this final check before launch. It's happening throughout the entire journey.
Yeah. Exactly. It's most effective when it's integrated into all those other stages. So even during design, you might have reviews to spot potential issues early on. And during development, programmers often write what are called unit tests to make sure that like individual parts of the code are working correctly. Like let's say you're building a login screen. A unit test might check if the password validation works as expected, whether it rejects weak passwords and all that.
So each little component gets checked as you're building it. That's smart.
It is. And again, it's all about finding those problems when they're small and easy to fix. Much better than trying to untangle a huge mess later on.
Right. You don't want to be playing whack-a-mole with bugs. So I know there are different ways to actually test software, right? It's not just one size fits all. What are some of the different types?
Yeah, you're absolutely right. There are different approaches. So first off, you have manual testing. This is where, a human tester actually interacts with the software directly without using any automated tools.
So it's like hands-on, exploring the software as a user would.
Yeah, clicking buttons, entering data, seeing how it responds. And then you have automated testing, which uses specialized software and scripts to run those repetitive tests quickly and efficiently.
Ah, so that's where technology helps speed things up a bit.
Exactly. Now, in terms of what you're actually testing, there's functional testing and non-functional testing. Functional testing, you're making sure the software does what it's supposed to do, according to those initial requirements we talked about. For example, if you have a button that's supposed to save some data, you're checking if it actually saves the data correctly.
Okay, so does it do the things it's designed to do?
Exactly. Non-functional testing, on the other hand, it's about how well the software does those things. So things like performance, how quickly it responds, security, how well it's protected against hackers, and usability, how easy and intuitive it is to use.
So functional is about what it does, and non-functional is more about how it does it.
Precisely. And then there's regression testing. Imagine you fixed a bug or added a new feature. Regression testing is all about making sure those changes didn't accidentally break something else that was already working.
Like making sure you didn't create new problems while fixing old ones.
Exactly. It's about ensuring that your fixes or updates don't cause the software to regress back to a buggy state.
Right, you don't want to take 2 steps forward and 1 step back.
Exactly. And all these different types of testing, they work together to give us a comprehensive view of the software. Is it working? Is it secure? Is it easy to use?
I'm getting a real appreciation for the complexity of this. So are there any ground rules or philosophies that guide good software testing?
Yeah, there are definitely some key principles that, every good tester knows. One of the big ones is that testing, it can show you that bugs exist, but it can never prove that there are no bugs. You can find and fix a lot of problems, but you can't guarantee that you've caught them all.
That's kind of humbling, right?
It is. And then there's the idea that exhaustive testing, it's just impossible. You can't test every single possible scenario, every input, every user action. There are just too many.
So you have to be strategic about it.
Right. Focus on the high-risk areas, the things most likely to cause problems. And we've already touched on this, but early testing is so important. The earlier you find a bug, the easier and cheaper it is to fix.
Definitely makes sense. Catch those bugs while they're still little.
Exactly. Then there's something called defect clustering. Research has actually shown that most bugs tend to hang out in a small portion of the code. It's weird, but it's true.
So there are bug hotspots.
Yeah, kinda. So if you know where those hotspots are, you can focus your testing efforts there. And then there's the pesticide paradox. It's a funny name, but basically if you keep running the same tests over and over, they become less effective at finding new bugs.
Oh, so the bugs, they kind of learn to hide from those tests.
Yeah, you got to keep things fresh, mix up your tests, come at the software from different angles. And finally, testing is context dependent. How you test a mobile app is going to be different from how you test, say, an airplane's navigation system, right? The type of software, what it's used for, all of that dictates how you approach testing.
Right. You got to tailor your approach to the specific software and what it's supposed to do.
Exactly.
So we've talked about the importance of testing, the different types, the principles, and it all sounds great in theory. But what are some of the challenges that real-world testing teams actually face?
Oh, there are plenty, believe me. One of the biggest is time. Development teams are always under pressure to release software quickly, which can mean less time for thorough testing.
So the pressure to deliver fast can clash with the need to test thoroughly.
Yep. And then there's the fact that software is getting more and more complex, right?
Yeah.
Think of all the different systems and components that have to work together seamlessly. It's a lot to test.
So it's not just about testing individual pieces, but also how they all work together.
Exactly. And sometimes, those requirements change during development. which means more testing, more adjustments, more headaches.
Ah, so it's not always a smooth, predictable process.
Definitely not.
Yeah.
And communication breakdowns between teams, those can cause problems too. If developers and testers aren't on the same page, bugs can slip through the cracks. And lastly, sometimes the environment you're using for testing, it doesn't perfectly match the real-world environment where the software will actually be used.
So a bug might show up in the real world that you never caught during testing.
Exactly.
Wow, this is a lot to consider. It's clear that software testing is not just about technical skills. You need good communication, project management, the ability to adapt to changes.
Oh, absolutely. It's a real team effort, and it requires a whole range of skills.
All right, so let's do a quick recap for our listeners just to make sure we're all on the same page.
Sounds good.
So, key takeaways. Software testing is essential for building high-quality software that actually works and meets user needs. It's not a separate phase, it's integrated into the whole development process. And testing early and often is the best approach.
Right. We also talked about all the different types of testing, from manual to automated, functional to non-functional, and how they all contribute to a comprehensive evaluation.
And we can't forget those guiding principles, like remembering that testing can only reveal the presence of defects, not prove their absence, that exhaustive testing is impossible, and that early context-aware testing is crucial.
Yep, all important stuff to keep in mind.
This has been super informative. Now I'm curious, and maybe this is something for our listeners to ponder as well. Given everything we've discussed, is there maybe an unexpected area where early testing could really pay off?
That's a good one. Well, thinking about the principle of context-dependent testing, what comes to mind is usability testing. Getting real users to try out the software, even in its early stages, can reveal things that traditional testing might miss.
So getting that user feedback early on, seeing how people actually interact with the software.
Exactly. That can help you catch design flaws, confusing workflows, things that might not be obvious just from looking at the code. And fixing those issues early can save a lot of time and money later on.
That's a great point. It's like you're not just testing the software itself, you're testing the whole user experience.
Exactly. Get that feedback early, and you can build a product that people actually enjoy using.
Fantastic insight. Well, I think we've covered a lot of ground today. We've explored the world of software testing, its importance, the different types, the principles, the challenges, and even some areas for future exploration.
Hopefully, our listeners now have a much better understanding of what goes on behind the scenes to make sure the software they use every day is reliable, functional, and hopefully even enjoyable to use.
Absolutely. So for anyone who wants to dive deeper into this fascinating field, consider this your starting point. There's a whole world of knowledge out there waiting to be explored. Thanks for joining us on The Deep Dive.